through beacon processor changes I made in this PR. So I've introduced two new kind of worker pools. We have the IO bound workers and the CPU bound workers. So before this change, we kind of had one worker pool that was just the number of CPU threads available on the machine. And if they're, as we schedule tasks in the beacon processor, we would, decrement the amount of workers we have available. And when one of those work events was done, we'd increment it back. And so we can never queue more than the amount of work than the amount of workers we have in that pool. Now the thing is that Lighthouse processes many different types of work events. Some of them are CPU bound, for example, like KZG verification or reconstruction. And some of them are kind of IO bound. So you could think of like requests to like a server, I don't know, database stuff, things that aren't CPU heavy. And so, we thought it made sense to maybe like have a pool of workers for these like IO bound tasks and a pool of workers for the CPU bound tasks. And so for the IO bound tasks, we could have a pool of, right now I have set to like 100 workers, but maybe that number can be bigger or smaller depending on maybe some of the metrics we get later. And then the CPU bound workers will still be just the number of CPUs available. And as we schedule tasks, we can categorize work events into these different types. So, I've added like this like work category enum, and then based on the work type, it'll either be IO bound or CPU bound. I still need to go through and make sure all the different work types are categorized correctly, but this is just like the general idea. And then in the beacon processor itself, we have these two queues, or these two pools. And then when we try to get the next work item from the queue, which in current unstable is like this very long chain of if-else's where it's ordered by like the priority that we have set. So like the first priority that we have is like processing chain segments, and the priority just goes down from there. And so now we have this like predicate that we feed into all these different work queues that returns true if we have available workers for either the IO pool or the CPU pool. So like this chain segment queue, for example, chain segment work events are they're IO bound tasks. And so if this predicate evaluates to true, we pop from the queue. If it evaluates to false, we don't pop from the queue. And this is the predicate right here. So the work category for chain segment queue is, in this case, IO bound. And if this boolean is set to true, which is spawn IO bound, is just this right here, right? So if the current IO bound workers is less than the max, this is true, and that means that we can pop from this chain segment queue and process this work event. I might have said that chain segment queue is IO bound, but I believe it's actually CPU bound. But whatever. Anyways, you get the idea. So this is kind of like the meat of the change, is like this changing that big chain of if-else's to it's also a chain of if-else's, but with this pop if that takes in a predicate. And that kind of allows us to manage the IO bound work events and the CPU bound work events separately. Later on, we might want to create like a rayon pool like worker pool just for rayon tasks. We can do a lot of things with this, and the goal here is to maximize like the beacon node so that I can efficiently queue as many work events as possible, obviously without overloading the machine. But we just want to be able to do more things concurrently. I believe that there are there are certain types of work events that we should be able to just queue up concurrently without affecting like node performance, especially some of these IO bound tasks. And so yeah, that's the change. The PR itself is built on top of this work queue refactoring PR that I have. Hopefully, should be merged into it stable soon. But yeah, PR itself isn't too big. A lot of it is also summer factoring. So I moved the all the like work enum definitions and the work type and the work category to their own file, just to clean things up again. So that's actually a good chunk of the diff. So again, it's just like moving stuff around, and then the rest of it is just adding, instead of having this one worker pool, we have two of them, and then handling them appropriately. So yeah.